In parallel, something interesting happened also around 2014. JPEG committee had this observation that the world of compression, and especially image and video compression, even audio to some extent, is playing a game that is increase the complexity and get better compression ratios. The problem is that increasing complexity doesn't come for free, right? You need more resources, while having too much resources is not always good. So around 2014, JPEG started to have a parallel path by saying, what about becoming a little bit more resource aware and find ways that the complexity becomes actually a very important requirement, even sometimes above some others. And Jpeg Xs was created because of that. So Xs actually doesn't stand for extra small, as you see sometimes on clothes. It stands for extra speed, which has in it, that for the same resources, Jpeg Xs will run faster. Now, the priorities under Jpeg Xs are a little bit different. The first priority is actually that the quality should be completely transparent. Impossible to make the difference between an uncompressed content and a compressed, uncompressed content. Compressed, decompressed, sorry, content. But then immediately after that, the other priority is complexity. And then latency. A lot of applications, they really require latency, low latency these days. And then compression ratio is of course there too, because you don't code and compress for any other purpose than reducing the size, but the reduction of the size is not the most important and priority here. You have the quality that is the most, complexity and low latency that are second, and then you have compression. Well, get the best you can, but don't sacrifice the first three. And if you look, you see that there are actually a lot of applications around where compression didn't really find a way to, but actually Jpeg Xs is now doing that. So these basically are especially in areas like drones that needs to rely on some sort of imaging sensors and or cars that are self-driving or surveillance that requires very, very low latency. And you can imagine here the quality is extremely important. You cannot possibly accept any distortions in these cases because lives will be on matter at stake. And in addition, latency is very important. If you have a car driving 120 kilometers per hour or more, a fraction of a second can be the difference between life and death. So latency becomes very important. But there are others too, right? You can imagine, for example, 5G is known to be a next generation of mobile communication that, of course, as expected, will have a far larger bandwidth, which, by the way, means maybe compression is not as important because you have much larger resources at disposition in terms of bandwidth. But one very important added value of 5G is ultra low latency, right? So there are configuration of 5G networks that talk about 1 millisecond latency end-to-end. These are, of course, for applications that like self-driving cars, where you could actually send from one car to another and you want the information in form of images or something else, but it has to arrive very, 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 very quickly in order to do something useful in a very, very short amount of time. So it doesn't make sense, for example, to use, I don't know, H.264 or H.265 or VVC in such a network, right? Because, well, in order to encode a video, regardless the complexity, just inherent design of a video is in such a way that you have to wait for a few frames in order to be able to start coding. Well, waiting a few frames means tens of milliseconds of latency. Then 5G actually can offer you 1 millisecond. So there is no codec designed for this kind of applications. And that's where Jpeg XS kicked in. Again, if you go and look at the Jpeg XS, you see that the diagram, the block diagram, is pretty much the same as JPEG 1, JPEG 2000, and JPEG XR. However, there are a little bit some additional tools that have been added to it. For example, the rate prediction and the rate control, in order to actually get rid of buffer. And no buffer means low complexity. No, sorry, low latency. And that's very, very important. So there also, you could see that this is, again, a second generation together with JPEG XT of the type of architecture that is used in encoding in JPEG. I don't want to spend too much time on that, but interestingly, because there is, of course, 25 years of distance between JPEG 1 and JPEG XS, you could actually, and this chart, I don't want to go into detail of it, but in fact, JPEG XS does a better compression than JPEG. Well, you would say, yeah, but it's expected. Yeah, but it's 10 times less complex, and it is better in terms of compression efficiency. And by the way, the proprietary solution called ProRes by Apple is actually doing worse than both JPEG 1, 30 years old, and JPEG XS. These are type of things that, of course, Apple is not going to tell you, right? But if you can try it yourself and you will see. Emotion JPEG is better than ProRes. There are also some extension of JPEG XS. It's worth mentioning because it will be useful for what follows. JPEG XS has a special tool that allows you to compress the sensor array directly without it being first debired or demosaicked. For two reasons. One is that, we all, or at least I suppose many of you, since you are in this meeting, you are all interested in compression. And, it's actually a little bit nonsense that we have the large majority of sensors around us, visual sensors, they actually have only one matrix, right? In which you have at points, some red and some green and some blue sensors. But the first thing any capture device does is that it's going to debire it or demosaicing it, which means that you multiply the amount of information by 3 on the sensor device often. And then the rest of us, we have to do a lot of efforts to compress it again. So we actually expand it, and then we try to compress it. And we ignore the fact that many of these pixels that we created, actually 2 out of 3, we actually created them ourselves. They're synthesized. They are not needed, right? And we try to come up with algorithms to undo what we did in the first place ourselves. So in many applications, you actually don't need to go through this debiring. You can actually go and compress. So none of the existing standards up to JPEG XS was able to do that. And now we are starting to see, especially with JPEG XS compression. And another thing also that motivates this type of compression of the sensor array itself directly is that the only reason we actually do debiring is because of humans. A machine doesn't need to have the debiring, and especially an AI based, artificial intelligence based system doesn't need these extra pixels. The only reason we have debayering is that because these images look nicer to humans. That's why we do this. And the more and more machine coding for machines is becoming an important issue, because the majority of images today are for humans, but tomorrow it won't be the case. They will be for machines. So maybe it makes sense we see what machines like more than humans like more, right? And this was one of the first things that JPEG committee did in Jpeg Xs, which is now finished. And Jpeg Xs, by the way, is now being deployed in many places. So it just finished a couple of years ago to be published, but it's actually has started already to be used, especially in cloud environments, and for professional companies like Amazon are actually using it for cloud editing, and Hollywood is using it in many places. The same ideas actually found their ways also in JPEG 2000. JPEG 2000